So the multiple regression model allows us to analyze more than one independent variable. So there may be lots of things that affect, for example, the level of debt payments that we are able to make. And so not just our income. So using multiple regression, we're able to add in a bunch, assuming an infinite amount of independent or explanatory models to variables to test and see whether they truly have an influence and how much of an influence they have over our y or independent or dependent variable. So again, we can use the multiple linear regression model. It's just an extension of the least squares regression model, where we have multiple basically slopes. Now they're not really multiple slopes, it's still only one line, it's still only one slope, but there's basically multiple beta 1s, still only one beta null, but the beta 1s are the parameters that were the level of influence, let's say, that the independent variables are exerting over the dependent variable. Now again, these formulas are very nasty to have to do by hand, and thankfully we have Excel to do them in. Now, we do have to, again, as I mentioned on the previous slide, modify our interpretation of a slope. We can't really say that that is the amount that causes the change. We can say that holding all other variables constant. So we're going to get the slope of income and say this is the predicted change in debt payments based on the change in income, holding everything else constant. And then we'll do the same for unemployment, because that's what we're going to add. That's the variable that we're going to add to our regression analysis, and we'll be able to determine its level of influence holding all other variables constant. So again, we're going to go back to that introductory case, and now we're going to look at the unemployment rate add that in as a second independent variable. So let's jump over to Excel and look at that. So I'm back in Excel, and you'll notice that I just closed out my previous session without saving it. So now I've got my data arranged where debt is on the left, and then income, and then unemployment. I want to make sure when I'm doing it this way that it doesn't matter which comes first, but I want to make sure that all of my X or independent variables are together. So remember, debt is my Y or dependent variable, and now I have two X or independent variables, income and unemployment. And so I want to make sure that income and unemployment are side by side or together. That's going to make it a little bit easier when we run the model. So again, I'm going to go up here I'm in my data tab. I'm going to go to a data analysis. Go to data analysis. It doesn't want to open for me. Here we go, data analysis, and I'm going to choose regression again. Now, my Y input range is my debt level, but notice that my X input range is both income and unemployment. I want to grab them both all at the same time, so that's why I said they need to be side by side. It is possible to put two variables in there that are not side by side. It's just harder, so it makes your life easier if you write it where maybe Y is on the left and then all of your X variables going that way, kind of as the equation is written, as long as you're not doing a scatter graph. Now, I do have labels. I want my output range to be just F1, and I'm going to press OK. So now I've got my statistics here, my data here. Notice in my summary output, now I have intercept as well as income and unemployment. Again, I want to highlight these. So notice now that the intercept has changed. It was what, 210 when we just did one independent variable, but now it's 198, so it's shifted a little bit. Now in this case, we can't really say, it doesn't make sense to say if income and unemployment were 0, then debt payments would be 198. because, well, first of all, unemployment is never zero, and that's not realistic. So that's what we were saying earlier in the first video, that it doesn't always make sense to interpret the intercept as being if all the independent variables were zero. Sometimes it does, sometimes it doesn't. But we can say if we were graphing this, this is where that trend line would cross the y-axis. So the income slope, if you will, which is really a coefficient, the income slope or coefficient is 10.51. So it's a little small, a little different than it was, again, when we just use ordinary least squares regression. So the way that we could interpret this would be to say, if unemployment was held constant, a $1,000 increase in income would result in a $10.51 increase in debt payments. When we look at unemployment, we see that it's roughly, what, 0.62? So we could say if income held constant, a 1% increase in unemployment would cause a 62-cent increase in debt payments. Okay, so notice again, there's two things that we can learn from this. Number one is that both of these coefficients are positive, which indicates a positive relationship. So as income increases, debt payments increase. As unemployment increases, debt payments increase. Now, if we go back to the unemployment one and we look at that and say, you know, a 1% increase in unemployment, first of all, a pretty big amount, and second of all, but it's only going to increase debt payments by 62 cents. That's not a large amount. And you would be right, and we're going to talk about this more in the fourth video, but I just want to go ahead and point out now, notice this column of p-values right here. So we can see the p-value for the income is 2.98 times 10 to the negative 7. So that's a really small number. We could definitely reject the null hypothesis at the 5% confidence interval. But when we look at unemployment, it has a very high p-value of 0.929, which tells us that, by the way, we could not reject the null hypothesis at any level of common significance or confidence. So we wouldn't want to reject that. And so we can assume or conclude that unemployment really does not have a statistically significant effect on unemployment.